So we're going to write these in standard form today, not vertex form. So I'm just going to write the standard form so you guys can see it. Y equals ax squared plus bx, ladies, plus c. That's your general form. And when we did this a couple days ago, we did some vertex form. I gave you the vertex and we grabbed a point maybe off the graph, or I gave you the point, and then we could write the equation in vertex form. But if you don't have the vertex, this is when we're going to need this. So if I don't have the vertex, you're going to need at least 3 points. We need 3 points. You use this, it says when you don't have the vertex. And then why do I need 3 points? Okay, so you have in that lovely equation above there 3 variables that you don't know, which are the a, b, and c. Those are your 3 variables. If you have 3 variables, which I do, if you have 3 variables, to solve for those, you need 3 equations. So that's true. And we did systems in our last unit, so this will be sort of familiar to you, I think. But if you have 2 variables, you need 2 equations. If you have 3 variables, you need 3 equations. So to get the 3 equations, you need 3 points. And I'm going to show you in example 1 how to do that. Now, majority of what we're going to do today is going to be to use desmos to calculate these. But I do have to show you how to set it up to do it by hand because it's part of the standards that we have to do for the class. So just on this question, I'm going to have you do this, and there's a question like this on the homework. I promise this is not hard, it's just a little bit weird. So we're going to be given 3 points, and I'm just copying down that standard form so you guys can see it on the screen. You don't need it on your paper necessarily. But what we're going to do is use those 3 points to write 3 equations. It's not terrible, you just got to make sure you plug the numbers in for the right variable. So I'm going to grab the very first point. They list 3 points that are supposed to be on this parabola. So one of them's negative 336. Totally doesn't matter the order that you do this in. What you're going to do is you're just going to write an equation, and everywhere you see x, we're going to write negative 3, and everywhere I see y, I'm going to write 36. So in this y equals ax squared plus bx plus c, the a, b, and c should be variables in the equation. So that starts out with a y, so we're going to put the y coordinate of the point. That's the 36. And then it's a times x squared. In place of x, we're just going to put that negative 3, which is the x coordinate. That's squared, not the a. Then I'm going to do plus b times x, so I got to plug in x again. You plug in x in 2 spots in these equations. And then plus c. I'm just going to simplify this a little bit. So that first term, if you square 3 or square negative 3, what do you get? Like if I actually take negative 3 times negative 3? 9. Okay, so this first term is really 9a. The second term here, I just have b times the negative 3. We could just write that as minus 3b, and then you just have the plus c on the end. You never plug anything into that last term because that's the constant. So all of these equations should just end with a plus c. That's never anything different. Okay, now I'm just going to repeat that, but I'm going to grab the next point they give me. So the next point they give me is 0, 3. And again, I'm just doing the same process, but now I'm going to plug in 3 for y and 0 for x. So we'd have 3 equals, every time here you should see an a, b, and c before you plug the numbers in. So I'm going to plug in 0 everywhere I see an x. And so I'm going to have a times 0 squared plus b times 0 plus c. And hopefully this looks kind of familiar to you guys, because this is actually a y-intercept. If the y coordinate, or if the x coordinate 0, the 0 is just going to wipe these first 2 terms out, and you would just be left with c. So actually, I know this is just, it's very tiny, but this is an equation, and that equation is that c is equal to 3, so that would also give you one of your variables in that situation. Okay, and then I'm just going to do it one more time. I have to do 3 equations because I have 3 variables, so I got to use that third point, which is the 415. So again, just the x coordinate is going to replace x, and the y coordinate is going to replace y in that standard form. So I'm going to write 15 equals a, and then I'm going to put in 4 squared plus b times 4, and then plus c. And this one, each one of these you can kind of simplify a little bit. So I'm actually going to square 4. So 4 times 4 is 16. So that first term is really 16a. Second term, you got b times 4, so it's just plus 4b. And then I have just the plus c on the end. So I have to be able to tell you guys that you could show me, like here I could set up these 3 equations. So basically what's going on here, you'd have like the don't rewrite this. I'm just going to show you on my paper. So this would be like our last unit where we solved systems of equations. I'm not going to have you do that by hand. You just have to be able to write the 3 equations. But that would basically be your system, and we would do like substitution, elimination, something like that to solve this if we were going to do it by hand. But I'll show you how to do it on the computer because it's way faster. Does anybody have a question about just how to set up the 3 equations, though? Okay, now what we're going to actually do, and I'll show you how to write the equation. We're going to find the a, b, and c values, but I'm just going to have Desmos do it for us. That's the computer program we're going to use. So if you guys want to grab out your laptops real quick, I'm going to, let me see if I can pull this to the side so I can show you at the same time. So I'm going to open this from scratch so it doesn't look like this. Okay, so you want to type in just desmos.com. Now, if it brings up something after that, like if it says / like calculator or scientific or something like that, just get rid of it. Just go to desmos.com because we specifically need the graphing calculator part of this. You can do this on a graphing calculator, but not everybody has one, and frankly, it's way faster and easier to do it on here. So just on this page, you don't have to sign up, you don't have to log in, just click open graphing calculator, completely free. We don't have to do anything for it. Should look something like that when you open the screen up. Okay, now quadratic regression, which is what we're going to write down for this. All it is it's just the quadratic equation for, let me see if I can fit it, the data that you're going to plug in. In our case, we've got 3 points. So my data is the 3 points that I have given to me in that problem. I promise this is not hard, bless you. Okay, is anybody not seeing the screen on Desmos? Does anybody's not look like that? Okay, so what you got to do, there's a little plus sign on this far left side. Just click the little plus sign, and then third one down says table. We're going to make a little table with the points. So just click on the table, and then I'm just going to type like just these x coordinates. So I have like -3, and then we have 0, and then we have 4. Those are the x coordinates. And then just on the other side of the table, we're just going to type the y coordinates. So I'm going to do 36, 3, and 15. All right. Anybody not seeing the table or having a problem with that? Okay, I'll come look at it. When you're done typing in those points, what we're going to do is we're going to run a quadratic regression and have the computer just do it for us. Anybody else having trouble? Now, all you have to do, once you have this, there's like a weird, I don't even know what it is. There's a weird icon like right up here by the 1. It looks like dots in a line there. That's what you want to click on. And I'm just going to click like it says add regression. Okay. Now, the computer program here is defaulted to just start with what we call linear regression, which is just the equation of a line. We are working with quadratics. So just this little drop-down menu here, you're just going to click that and pick quadratic regression. And that will tell you right underneath here the equation that goes through those 3 points. Let me move this so you can see just a little bit. You can kind of, this isn't the perfect graph, but you can kind of stretch this around, and I'll be happy to help you manipulate that. But you can kind of, what was the other one? We had 336. Like those points should all be on the graph. And if you can see them, I kind of stretched that out a little bit. But that parabola like perfectly goes through those 3 points. The other way I know it perfectly goes through those points, do you guys see this little r squared in the corner? If this is 1, that means that is the exact equation that goes through that. We won't always see that, especially if we have a bunch of data values and we're estimating, but this should be nice numbers that are going through here, and this is a perfect equation for that parabola. So we're just going to write that down. That's literally the equation. So your A value would be 2, your B value would be -5, and your C value would be 3 in that standard form. So if we want to go ahead, let me just write the equation. So we have y equals 2x squared. Now I already forgot what it was. Minus 5x, I think. Yes. And then plus 3. And I just put that right in front of what I was writing down. But that equation goes through those 3 points. That is a quadratic in standard form. Now this is not something I would ask you to graph by hand because the vertex here is going to be a weird number, because if I did negative b over 2a, we'd have like positive 5 over 2 times 2, so it would be positive 5 over 4. So it's going to have a fraction or a decimal for the vertex, but we can write the equation just knowing the 3 points. So what I want you guys to try and do, try to write the equation for the quadratic that goes through these 2 sets of points. Can't drag this off the screen any further than I've got it. Put these 3 points in, and you could just literally, you don't have to do anything else. If you want to, you can type over the top of them and just use your arrow keys. Don't hit the return because that'll give you another button. I don't know why I just put -21 there. Just put the x's in for x and then the y's in for y. You can just use the arrow keys. Make sure if it's got a negative that you put a negative, and make sure you line up the x coordinate with the x coordinate. And then you'll be able to see the equation right underneath it. Once you have that quadratic regression selected, it should kind of default to that. If you want to move the graph at all, and I'll come help you if you have a question, but literally you can just like kind of grab the x or y axis, like scrunch this. If you want to move it, you can just move it around with your fingers, but it's not too bad to do if you have the touch screen. So if you want to look at that more closely, this one is another example. It perfectly goes through all 3 of the points if that R value is 1, so you can check that there. But go through and see, I just did that one basically, but see if you can do it for those two sets of 3 points in example 2 there. See if you can figure that out on the decimals, and I will be happy to help you with that. The A value on the second example is a fraction, yes, or a decimal, either way. The decimals is going to give you a decimal, it will not give you a fraction. So you can write either decimal. Let's see if you can plug in those 2 sets of points. Write me what the equation should be that goes through them. I'm going to move mine away from here. Go ahead, try that on your computer. Make sure you're... Okay. Anybody feeling good about the... Well, I kind of did the first one, but I didn't write it down. What equation did you guys get for the first quadratic? Oh, I thought you were raising your hand. What did we get for the first one? Perfect. Negative 1x squared plus 6x plus 5. Anybody not get that or want me to look at their computer? Okay. Anybody get the second one? Those 3, I had -4, -15, -8, -7, and 635 were the 3 points they gave you. What was your quadratic equation? The A value should be a decimal or fraction. 0.5, yes. This was 0.5, or you could do 1/2 x squared. What was the rest of it? Plus 4x minus 7. Perfect. Is anybody having a question? It's not terrible to do, I promise you. Okay, now on the back. Now this, I'm going to ask you a little question before we start this. So this gives me a table that has times and temperatures for a city in Sacramento, California during a certain day in the month of October. So nice weather here, obviously. And we're going to do a regression on this. We're going to have a little bit more data here because I've got 6 different times and temperatures. So we're going to have 6 points on our graph instead of 3. And this is going to be kind of like making a scatter plot. If you remember doing that in Algebra 1, like we do a trend line, but we're going to do it with a quadratic model. So we're just going to fit a parabola to it. Before I type in the data, though, I'm going to use the times for x and the temperatures for y. But let me ask you a question about this. So the times... I have like 8 a.m., 10 a.m., 12 p.m., then it goes like 2 in the afternoon, 4 in the afternoon, 6 in the afternoon. would you do anything to change any of those times? If I'm talking about the temperature throughout the day, would you just type those times in as your x values, or would anybody do anything different with those? Now, let me say something to you about that. So like 8 a.m. and 8 p.m. would both have an x coordinate of 8. Would that be okay?
8 a.m. is positive, 8 p.m. is negative.
Not negative. I like where you're thinking. But I don't want 8 a.m. and 8 p.m. to be on the same line. Anybody know how to take care of that with time? You guys ever heard of military time? Do you know what I'm talking about? You got to use military time here. Okay, so literally all it is, if you've never seen it before, it's no big deal. But like 8 a.m. would be 8, 9 a.m. would be 9. Once you get in the afternoon, because then the numbers would repeat, what you do after 12 is you just add that number to 12. So instead of 2 p.m., they'd call it 1400 hours if you were doing military time, but it's just so I'm not using the number 2 a second time. So 2 a.m. and 2 p.m. would be two different values. 2 a.m. would be 2, but 2 p.m. we'd put in 14. Okay, so for 4, just add 12 to it if you're in the afternoon. This would give you 16. If you're 6, just add 12 to it. That will give you the military time. So that's just important because 8 a.m. and 8 p.m. are not going to have the same temperature. So we want to just kind of represent. So if you have time, something like that, the afternoon hours, we'll just use military time. So other than that, I'm going to use this table, and we're going to plug this into our lovely table on the desmos. Okay, so I'm just going to start, and I'm just using the arrow keys to go down. So I'm doing like 8, 10, 12, and then it's just like 14. Oh no, I just typed the 2 in the same box, sorry. 8, 10, 12, 14, 16, 18. And then just come over here and put the temperatures that match up. So I got like 52, and then it's going to get warmer through the day. Now, when you guys see these, I'm going to drag my graph over here a little bit, so hopefully you can see it a little bit better. And depending on how your graph is, you might not have all the times, or sorry, the temperatures might not all be there. I got that dragged in a different format than yours probably, but you can see like the points aren't all exactly on. And if you look down in the corner for my quadratic regression, that r squared is like 0.9884. That's close to 1, but it's not perfect. So 1 would be perfect. So since it's not perfect, you can see like a couple of these points are like a little bit off, and that's okay. We're doing a quadratic regression is the best estimation of the data that we have. So this is perfect for this graph. What I'm going to have you guys do, and you can see down here, now these coefficients in front of like your x squared and your x are way different numbers. They got a bunch of decimal points. I'm just going to ask you to try to round to 2 decimal places to actually write this down. So let me scooch this over. So to write my lovely quadratic regression, I'm going to come over here. We're just going to write y equals, and then I'm just going to go 2 decimal points on each of those coefficients. I know that first one has to be negative because it's going upside down. And hang on a second, I feel like I got one of these. Don't write mine down. I got one of these numbers is a little bit off. Oops, I put a 75 here instead of 76. Okay, there we go. My fault. Now, this should be negative. I'm going to do 0.47 x squared. And then I'm going to do plus 14.72 to the nearest. I'm just doing 2 decimal places. And then minus 36.12. So that would be a parabola that really well estimates what we've got going on in that set of data values. Okay, now the question right under that, after you got that data in, it says use your model to predict the high temperature for the day. Now, that doesn't have to match the data values that we put in, and it actually won't here. So let me show you how to do this real quick. If you have this on your calculator, whoops, I've got my quadratic regression, right? If you actually click on the parabola, like the little black line there, or curve, if you come up, there should be a little gray point. because it'll snap to show you the zeros, and it'll actually also snap to show you the actual vertex. So I'm just going to click on that real quick so I can hold it on the screen. But all I did, just click on the parabola, and then you can click on specific points. It'll make like a little gray point where the vertex is. So the vertex would be my lovely maximum temperature and then at the time. So let me just write down that point real quick. Again, I'm just going to round to 2 decimal places. So this is like, ooh, actually to 2 decimal places. This would be 15.7 for the time, and the temperature is 79.38. So that was the vertex. I just wrote down the vertex, just got that from the graph. Just click on the parabola, and then it should little gray out point snap to it to give you the vertex. Or you could do negative b over 2a. If you wanted to do negative b over 2a and then plug it in, you could get the same thing. I'm just using the graph because we had it on the graph. Now, this says use your model to predict the high temperature for the day. So that would be the y-coordinate of the point. And you guys can see it's a little bit off because actually in the list of temperatures, they went up to 81. So it's a little bit off, but that's okay because we're just using this as a model. The time would go for this part of the question. Now, if I have 15.7, anybody know how you could convert that to what actual time that would be? Because that's in the military time. Does anybody know what hour that would be? What would 15 be? 3. Okay, the 15, 3 o'clock. Does anybody know how to convert the 0.7 to minutes? How many minutes are in an hour? 60. Okay, so if this is like 15.7, here's all you would do. To convert that to minutes, just do whatever that decimal is times 60. That will give you the equivalent minutes. It's like a little conversion. So 0.7 times 60, this would be 42 minutes. So it would be 3:42 in the afternoon would be the actual time that you're going to get that high temperature. Does anybody have any question? Okay, now we're going to do one more. So this question's going to ask us about stamps. All right, so this lists, and it gives you years here, but it gives you a bunch of years and what the price of a stamp was in that year. So anytime I'm going to use time, we're going to make that our x. So let's make years our x, and the price of the stamp will be our y. We're going to estimate, and I'm just going to use the graph to do this, so we'll do this first. The one thing I want to work on with you guys here, this is a typical thing they'll do with data sets. If they're using years, right, people don't want to type in like 1981 or 19, they don't want to type in those huge numbers. So usually you'll see a direction like what you do in part B here. It says find a quadratic for the quadratic model for the data, but use 1981 as year 0. So I'm going to show you how to do this real quick, and it's literally just so you don't have to type in these big numbers. So if 1981 is year 0, I'm going to use 0 for my x value instead. What would you use for 1991? 10. Okay, now some of these get trickier to do because they don't go by consistent numbers. If you're not sure, just take the year and subtract the year you started off with, which is 1981. So like this would be 14. If I do 1999 minus 1981, you can just subtract, or sometimes people can figure it out pretty quick. 2001 would be 20 years after 1981. 2006, 5 years after that, so that'd be 25. 2007 is just one more year, so that'd be 26. 2008, one more year, that'd be 27. Or you can just take the year, subtract 1981. But we're just going to use those for our x values instead of the actual years, so we don't have to write such big numbers. So let me see if I can get this on the screen. I'm going to slide this over and type these guys into the table on the desmos. So we're just going to start with 0. That's going to represent 1981. Then 10, 14, whoops. I usually like to write it on the table so I can see what numbers I'm going to plug in. This has the most data of any of the questions we've done today. And then I'll go back and put the price of the stamp, which is just underneath the year. So start out with 18 cents and then 29 and on down. So we're just typing this in. and then I usually try to go back and look just real quick at my table to make sure I didn't screw anything up when I was typing anything in there. That all looks pretty good. So make sure you got this in, and then I'm going to drag this to the side so you guys can see the actual graph here. Now, this almost looks like a line if you're looking at it like on my screen right now. Okay, I'm literally going to grab the x-axis like with my fingers, and I'm going to like scrunch it together. I don't know how else to tell you what I'm doing, but just kind of squeezing the graph. And you guys will see this is a parabola, but it's like super wide. So we did the quadratic regression. You can kind of see my little points. They're all really close to the y-axis there, but this is a super wide parabola. Now, unfortunately, that a value there, if I round that to 2 decimal places, you would round that to 0. So what I'm going to do, I'm going to go out like 4 decimal places to write that first value for my quadratic model, and then the rest of them I'll go ahead and do like we were doing on the other questions, round to the nearest hundredth. So I'm going to write y equals negative. I'm going to do 0.00, and I just want to write a couple numbers. So 36. Then I'm going to do x squared. The rest of these I'll just go to the nearest hundredth. So then we have the 0.93 that would have an x next to it. And then I'm going to do 18.59. So that model we should be able to plug in for x. Whatever year we want, we'd have to figure out how many years it's been since 1989, but we could plug it in and kind of predict the price of the stamp. So the question right above here, it was like, in what year would the price of the stamp be 37 cents? Okay, so I'm going to show you like a really quick way to do it if you have the graph. So y is the price of the stamp, right? If you kind of come down here below the regression, we can put another equation under here. So I just like kind of clicked under that, and I'm going to write y equals 37. So I'm saying, okay, when would the price of the stamp be 37 cents? And then we can just go to the graph and see where it crosses our lovely model here. So I'm going to blow this up a little bit. If you click on it, it should snap to the point, like there'll be a little gray point if you want to click on it, and it will tell you, here's the exact point where the y value is 37 cents. So let me just jot this down. So this would be, let's see, I've got 21 point, let's say 59 here. And then the price of the stamp was the 37 cents, right? How would you guys figure out what year that is? If I've got 21.59, like what would you do to that to figure out actually what year it would be? So year 0 was 1981. My answer, or my x value that I'm looking at now, is 21.59. What would you do to the 21.59 to figure out what actual year that would be? You're going to add it. All you got to do, add it to the 1981. You started with 1981, so it's saying like 21.59 years later, you're just going to add it. Do 1981 plus 21.59. That puts you in 2002. And see if that makes sense. 2002, I just wrote it over here so you guys could look at the table. So sometime between 2001 and 2006, you're going to hit the 37, right? Because we go from 34 to 39. So based on our model, it's going to happen in 2002. Okay, don't worry about this one. We had a big, long discussion about this morning, but don't worry about it. I do want to know, can you predict when the cost of the stamp would be 60 cents? I'm going to literally do like the exact same thing I just did. Just grab your desmos, and now if I want to know when it's going to be 60 cents, just type in y equals 60. That'll be this red line that you guys see on the graph, and then we can figure out what year that would be. So I'm getting 57 point, let's say 02. So 57.02, and then that was when the price of the stamp was 60 cents. All you have to do to actually figure out the year is just add that 57.02, add that to 1981, because it's years since 1981. I'm not on the screen at all, Theo. And if you guys do that, you should get 2038. based on our model. That's when that would hit that price. Does anybody know what the price of the stamp is right now?